Assalamu alaikum and good day to each and everyone. Last time we have talked about the rectilinear motion of a moving vessel, right? For this week's discussion, we will be discussing, or we will be talking about a rotating vessel, or the rotating vessels in motion. So in general sense, last week we have talked about a vessel, a moving vessel in which it moves in a rectilinear motion. It's either in horizontal motion, inclined motion, or vertical motion. Pero sa week na ito, ang pag-uusapan natin is the behavior of a vessel in rotating motion. Meaning to say, nag-rotate yung vessel sa case na ito. Okay? So, when a fluid mass is rotated about a vertical axis at a constant angular speed, omega, take note yung omega dito is the angular movement of angular speed of a vessel. And take note as well, its unit must be in radius per second. Okay? Radius per second. Every particle experiences a normal acceleration of an. An is the normal acceleration, which is equal to v squared over x is equal to omega squared times x, where x is the particle's distance from the axis of rotation. This one, diba? x1, x2. This acceleration causes an inertia force, that is the centrifugal force or reversed normal effective force, which is equal to mass times normal acceleration or weight over g times omega squared times x. For the variables class that we are using for rotating vessels, kindly refer to these figures for you to easily follow or for you to easily identify the formula we are using. Okay? So, for example, this figure 1a, this 1a, this is, imagine this is the vessel. Tapos, girotate natin yung vessel in this motion. So, whenever you are rotating this vessel in motion with this angular speed, tapos may radius, my height. So, this is actually the behavior of a vessel being rotated. Okay? So, again, as you can see in this label, this is the paraboloid revolution of a vessel. Okay? So, you have this weight. Okay? Kung i-rotate natin yung vessel, ito yung magiging free body diagram ng forces. So, if we are to consider this free body diagram, we can draw this right triangle. We have this downward force or downward weight, which is equal to mass times gravity. Tapos we have this normal force that is perpendicular to the surface. Okay, this point, perpendicular sa surface na ito. And we have this centrifugal force which is equal to weight over gravity times omega squared times x. Okay? So, kung titingnan natin yung trigonometric function in terms of tangent, ang ma-derive natin na formula is tangent theta is equal to omega squared times x over g. Okay? Take note of this. I hope everyone is very much familiar on how to use the trigonometric function, or how to convert, or how to devise formulas using trigonometric function in relation to a given triangle. Okay? So, yung tangent theta is the slope of the paraboloid at any point x from the axis of rotation. So here, we have this y. Yung value ng y is omega squared x squared over 2g. Tapos yung h is equal to omega squared r squared over 2g. As you can see yung difference, yung sa y, ginamit is x. Pero yung h, ang ginamit is in terms of radius. Okay? Tapos yung omega dito is the angular speed in radian per second. But take note, for the conversion of radian, 1 radian per minute is equal to pi over 30, that is radian per second. Okay? So volume of paraboloid of revolution, that is 1/2 pi r squared times h. Okay, these are actually the different cases that we might be engaging in a rotating vessel. We have this when yung y over 2 is less than the less than D, that means there is no liquid spilled. Okay? Pero kapag yung Y over 2, this one, is equal to D, liquid surface just touching the top rim. Meaning to say, kapag yung Y over 2 is equal to D daw, like equivalent sa D, ang ibig sabihin is yung tubig mismo, itong tubig dito, is nasa rim mismo ng vessel. Meaning to say, there is no liquid spilled. Pero, kapag yung Y over 2 is greater than D, meaning to say, may spilled yung liquid or may natapon na tubig. Next, kapag yung Y, this Y is equal to H, meaning to say the total height, the vortex is at the bottom. Ang vortex na ibig sabihin is itong vortex. Yung vortex na ito is nasa bottom, meaning to say, na-touch yung bottom ng vessel. Kapag yung Y is equal to H, ibig sabihin nun is may natapon na tubig. There is this liquid spilled because of this condition. Next, kapag yung Y na naman is greater than H, the vortex that is imaginary is below the bottom. Meaning to say as well, there is this some liquid spilled. Again, yung vortex is actually the tip of the parabola. This one. Dito sa first 5 cases, these are for liquid surface conditions in which yung cylindrical containers are open. Pero kapag close yung cylinder or yung container natin, ito yung conditions. Ito yung mukha, kapag close yung container, there is no pressure at top. Next. With pressure at top, kapag may pressure over Y na remaining or pressure over gamma na remaining. For pipes and tubes, this one, we have this without initial pressure inside, tapos may with initial pressure inside. Okay? So that is all for the concept behind rotating vessels, which involves the closed cylindrical vessels, tapos yung open, meron din tayong pipings. Next is, in next video, I will be providing you some examples which correspond to rotating vessels.